The role of forensic chemistry in criminal investigation. Forensic chemistry plays a vital role in criminal investigation, providing a crucial evidence to help solve crimes. By applying the principle of forensic chemistry, investigators can analyze physical evidence, identifying substances, and reconstruct a crime scene. As what Edmund Lockhart said, every contact leaves a trace, so it means there is no perfect crime, and we use forensic chemistry as a tool to solve a case. One of the most fundamental principles of forensic chemistry is the comparison of samples. Forensic chemists compare samples from a crime scene to known samples, such as those for a suspect or a victim, to determine if they match. Another critical aspect of forensic chemistry is the reconstruction of crime scene. By analyzing physical evidence and identifying substances. For example, if a forensic chemist analyzes the residue from a gunshot wound, they can determine the type of gun used and the distance from which it was fired. This information can be invaluable in reconstructing the events leading up to the crime. Forensic chemists also plays a crucial role in toxicology, the study of the adverse effects of chemicals on living organisms. Forensic toxicologists analyze biological samples, such as blood and urine, to detect the presence of toxins, including drugs and poisons. This information can be critical in determining the cause of death or injury in a criminal investigation. In conclusion, forensic chemistry is a powerful tool in criminal investigation, providing evidence to help solve crimes by applying principles of forensic chemistry. Investigators can analyze physical evidence based on the provided result of a forensic chemist and use it in court. As forensic chemists continues to evolve, the significance in criminal investigation will only continue to grow.
The uses of scientific evidence in forensic chemistry and toxicology. So let's start. Scientific evidence plays a crucial role in forensic chemistry and toxicology by providing the objective, reliable, and reproducible data to support investigations and legal proceedings. Like for example, identification of substances. Forensic chemistry or forensic chemist analyzes materials like drugs, explosives, and chemicals found at crime scenes. Analytical techniques such as chromatography, spectroscopy, and mass spectrometry are used to identify substances accurately. In toxicology, in cases like poisoning, toxicologists identify and quantify toxic substances such as drugs, alcohol, or heavy metals in body fluids or tissues. Toxicologists examine bodily fluids to detect the presence of prescription drugs, illegal substances, or alcohol in suspected overdose cases, helping to determine the cause of death or impairment. Providing evidence for criminal cases. Forensic chemistry, chemical evidence can be used in court to tie suspects to a crime scene. For example, identify blood stains, gunshot residue, or chemical traces left by explosives. In cases of DUI or driving under the influence, toxicology reports on alcohol and drug levels can be critical in providing intoxication and impairment. Authentication of materials. Forensic chemistry, it helps in determining whether a substance is genuine or counterfeit, such as testing and composition of materials involved in fraud or intellectual properties crime. Toxicology. In cases of alleged accidental poisoning or intentional contamination, toxicologists may test substances to determine whether they were involved in the crime. Trace evidence analysis. Forensic chemistry. Chemical analysis is used to detect trace amounts of substances that might indicate a connection between suspect and a crime scene, for example, gunpowder residue or explosive traces. Toxicology. Even minute amounts of toxic substances in blood or hair samples can provide evidence for poisoning or the presence of drugs over a period of time. Providing expert testimony. In both forensic chemistry and toxicology, scientists often serve as expert witnesses in court. They interpret complex scientific data in a way that is understandable for judges and juries, helping to establish facts in a case. In summary, scientific evidence in forensic chemistry and toxicology ensures that criminal investigations are based on objective, accurate data, which is essential for solving cases, ensuring justice, and protecting public safety.
First, what is physical evidence? Physical evidence, also known as real evidence or material evidence, refers to any tangible object connected to a crime or legal case. It's anything that can be physically examined and potentially analyzed to provide insights into what happened. So, there are many types of physical evidence. First is biological evidence. Biological evidence refers to any material originating from a living organism that can be used in a legal investigation. It plays a crucial role in forensic science, helping to identify suspects, like them to crime scenes, and reconstruct events. Biological evidences contains blood, saliva, hair, tissue, semen. Next is trace evidence. Trace evidence is a type of physical evidence found in small amounts at a crime scene. It is often microscopic and requires specialized tools and techniques to be detected. It is created when objects come into contact and transfer materials such as fibers, hair, paint chips, or glass fragments. Trace evidence contains fibers, paint, glass fragments, soil particles. Next is impression evidence. Impression evidence is a type of physical evidence that is created when one object comes into contact with another, leaving behind an imprint or mark. This evidence can be two-dimensional, like a footprint or a flat surface, or three-dimensional, like a tire track or subsoil. Impression evidence contains fingerprints, footprints, tire tracks, tool marks, and bite marks. Next is firearms and projectiles. This evidence helps investigators identify the weapon used, establish the trajectory of the bullet, and potentially link the firearm to a suspect. This contains guns, bullets, and casings. Documentary evidence. Documentary evidence, a crucial component of legal proceedings, refers to any written or printed material that can be used to prove or disprove a fact in a case. These documents can vary widely in form of content, ranging from official records and contracts to personal letters and emails. It contains handwritten notes, typed document, computer-generated materials. Next is weapon evidence. Weapon evidence is any physical object used to inflict harm or cause death in a crime. It's a critical piece of evidence that can be help identify the perpetrator, reconstruct the crime, and establish the intent behind the act. It contains knives, guns, blunt objects.
How to retrieve the physical evidence. A method or step-by-step guide for retrieving physical evidence. Identify and document the evidence. Carefully examine the crime scene or location of the incident. Identify any potential physical evidence that could be relevant to the investigation. Document the location and condition of each item of evidence using photographs, diagrams, and detailed notes. Assign a unique number or alphanumeric identifier to each piece of evidence to ensure proper tracking. Second, collect and package the evidence. Use appropriate method to collect each type of evidence, minimizing contamination or damage. For example, use tweezers for delicate items, sticky tapes for fibers, or electrostatic lifting for footwear marks. Package each item of evidence is a sealed container that prevents contamination and protect it during transport. Label its container with the item number, case number, collector identifier, date of collection, and a brief description of the item. Third, maintain chain of custody. Documents the movement of evidence from the time of collection to its final disposition. Each person handling the evidence should assign a chain of custody form recording the date, time, and recipient of the evidence. Fourth, store and preserve the evidence. Store evidence is a secure location designed for this purpose, limiting access to authorized personnel. Protect evidence from environmental factors such as heat, sunlight, and moisture, which can degrade its integrity. Fifth, dispose of evidence. Obtain written authorization from the client and the other interested parties before diffusing of evidence. Destroy. Document the date, time, and method of disposal, including witness signatures.
The historical development of crime laboratory in the ancient times. In ancient practices, early civilizations used basic forensic methods such as fingerprinting in ancient Babylon, 2000 before Christ era, and toxicology tests in ancient Greece. In 1814, Mattia Orfila established toxicology as a scientific discipline. In 1835, Scotland Yard detective Henry Goddard was one of the first to use bullet comparison to solve a murder case. French scientist Alphonse Bertillon developed the anthropometric system for identifying criminals in the 1870s. In 1892, Sir Francis Galton introduced fingerprint classification, and in 1901, Karl Landsteiner discovered blood types, which later became crucial in forensic science. The historical development of crime laboratory in international. First, in the early beginnings of 19th to 20th centuries, the concept of forensic science emerged in Europe, with pioneers like Hans Gross and Edmond Locard establishing the foundation of forensic science. First crime laboratories in the early 20th century. The first crime laboratory was established in 1910 by Sir Edmond Locard. He set up the first crime laboratory in Lyon, France, pioneering the Locard's exchange principle. In every contact leaves a trace, marking the beginning of modern forensic science. Next is the International Association of Chiefs of Police or IACP 1922. The IACP was established and its Forensic Science Committee played a crucial role in promoting forensic science globally. The historical development of crime laboratory in USA. The Federal Bureau of Investigation or FBI was established its laboratory in 1932, which became a model for crime laboratories worldwide. Second, American Society of Crime Laboratory Directors or ASCLD 1974. The ASCLD was founded to promote excellence in forensic science in crime laboratory management. The historical development of crime laboratory in the Philippines. PNP or Philippine National Police Crime Laboratory. In 1938, the PNP established its crime laboratory, which was initially located in Manila. The National Bureau of Investigation or NBI Forensic Laboratory was established in 1947. The NBI set up its forensic laboratory, which provides forensic science services to support investigations. The third is the Department of Justice or DOJ. Office of Cybercrime 2013. The DOJ established the Office of Cybercrime to investigate and prosecute cybercrime cases. The modern developments in crime laboratory includes the accreditation and standardization. Crime laboratories worldwide strive for accreditation and standardization, ensuring the quality and reliability of forensic science services. Second is the advances in technology. The increasing use of technology such as DNA analysis, digital forensics, and artificial intelligence has transformed the field of forensic science. The third is the international cooperation. Global cooperation and information sharing have become essential in combating transnational crimes and promoting forensic science excellence. Conclusion. Crime laboratories have evolved from small forensic units in Europe to vast networks of international, national, and local labs. Advancement in DNA analysis, digital forensics, and artificial intelligence continue to shape their role in modern law enforcement.